Okay, good morning and welcome everybody. Thank you for joining our first workshop of the day and the first workshop and session of the Toronto Machine Learning Summit on healthcare. So if you guys can hear me okay, please let me know in the chat and we will get started in a minute here. So for those who are, okay, great. Thank you, Faraz. Thank you, Marcia. Peter, I see some familiar faces here and some new faces as well. That's great. Hope everything's well. Wherever you're joining us from. It's great to see so many people. Thank you. So yeah, just a little bit of housekeeping before we introduce our first participant, Mohammed. We have the session starting tomorrow, so the actual conference with the tracks workshops today. The sessions tomorrow will be joining on Hopin on the platform, so you will have received an email for that. If you don't have that email, make sure to message us and we'll get you sorted out. But that will start tomorrow. There'll be some participating companies where you can get some booth swag, some virtual swag, and you can meet others as well on the platform. So thank you all for joining. Sincerely, I really appreciate everybody meeting. And I know this has been a weird year and meeting virtually, it's not ideal. But the plus side is that I get to meet some new people that I wouldn't have got the chance to otherwise. So I'm grateful for that. I'm also grateful for Mohammed, who's our first speaker this morning. Mohammed is somebody who I've known from afar, and I've just had a chance to meet him, which is something that I'm very grateful for because he has a ton of experience and he's willing to share that experience with you here today. Mohammed, if you're not familiar with him, is a data scientist and cloud solution architect with multiple years of hands-on knowledge and experience in leveraging advanced AI techniques to solve business problems. He joins Microsoft from Transport Canada, where he was previously, and where he was working in collaboration with Microsoft's account team. He played a key role in developing Transport Canada's big data and AI platform on Microsoft Azure. He also designed, developed, and led various machine learning projects, mainly in healthcare through private sector companies and hospitals, in computer vision, signal processing, geospatial analysis fields, and others. So Mohammed has a Master's of Science degree in biomedical engineering with a specialization and journal publications in machine learning and healthcare. It's a great pleasure to welcome Mohammed. Mohammed, thank you so much. I'll pass the mic to you.
Thank you so much, David, and good morning, everyone. The pleasure is absolutely mine, David, and thanks a lot for the intro. I'm certainly very delighted to be here and have this opportunity to welcome you actually to a journey that we're going to share within these 2 hours, starting from defining a business requirement in a healthcare scenario and having this walkthrough and be hands-on all the way going to the production and how we can have a service in production layer. Thanks a lot again, everyone, for joining to this session, and we're going to make sure that this will be fully interactive session, so please feel free to stop me if you have any questions. You can use the chat here, raise your hand, and David, I would be very thankful if you notify me just in case I'm missing some questions. And at the same time, please feel free to use the chat option to make sure that we will cover the content that you're looking for, and also it might be questionable for you here. And if my voice is not clear, please write down in the chat. I hope you can all see me and hear me properly. And I see that still people are joining, so welcome again to newcomers here. I wish we could have a chance to meet each other all in person, but of course we have this fortunate opportunity to still have it virtual. And that would be great if we could have an individual roundtable to get to know each other, but still having these online services, we have some options to break the ice and also get to know each other a little bit more. So let me share my screen, and I would like you to go to a website that I'm going to show you quickly. And I hope you can see my screen now. If you don't, please let me know. I can open the chat to make sure also I can monitor if anything you want to add here. So just to know your role, if you are a data scientist, if you are a machine learning engineer, if you are a medical researcher, what is your current role that you can add here so all of us can see to know a little bit each other more? And at the same time, I will be making sure that I will prepare the presentation and content in a way that would be most beneficial for majority of the people here. So if you go to just menti.com, again, if you cannot see my screen let me know. Okay, it sounds you can see perfect. Go to menti.com and just write down this code and answer the question of what is your code rule. Well, the first one came in, data scientist. Thank you. And I will be posting this in the chat just in case if it would be easier for you. Let me send the link first. And just use this code. Awesome, I see answers are coming. So we have ML scientist, data scientist, machine learning informer, very interesting, software engineer. This is fantastic. And I see some messages. Okay. So we still have data scientist as the highest answer. Perfect. Machine learning engineer, ML team lead. Awesome. Developer. This is cool. Still data scientist on the top. Lead data scientist, PhD students. This is great. We have votes from industry, academia, business development, quality analyst. This is fantastic. I just want to welcome again everybody. Thanks a lot for putting your time here. And I deeply hope that you will find this session very fruitful. I still see the answers are coming, so I want to keep it open. We're gonna come back to this actually to see what else is being added here. And for now, what I would like to do for this session, I will start with a introduction, some couple of slides. Well, the purpose of this session is not educating the capabilities on cloud and specifically talking about those options of cloud computing, specifically on Azure. It's all about defining a story, defining a roadmap for a journey, that what is the business requirement and how we can put these pieces of logos beside each other to create that product, which is a predictive analytics that we're going to provide. And of course, within the journey, we're going to touch and utilize some of the capabilities on cloud. And also I will be providing some introduction about those services, some capabilities, some of them in lower level. And then we're going to have a walkthrough through the codes. Some of them I have random before to save the time, make sure we will use the most out of these 2 hours. But some of them we will be executing together, those ones that are taking less time, and we will see the immediate outcome shortly together. Again, thanks a lot for the people who put the input here. Still, we see that data scientists and software engineers on the top. This is fantastic. Let me share the slide and start the intro. And as soon as we're done with those slides, which are going to be very quick, we will go to the Azure portal and start the journey together. Okay, I will open up my slide. Again, I'm now sharing a PowerPoint through the slides with full screen. If anyone cannot see, please let me know, and I'm checking the chat as well here. All right, so again, the purpose is about how we can having an end-to-end solution for a machine learning-based healthcare scenario journey, and how we can actually simplify through cloud computing all end-to-end on Azure platform. And at the same time, we are going to see how we can simplify this process in a way that it can be all automated, which is the main point of having that, and having also a scalability on our development journey that can come all the way how we can as a team develop codes and all these machine learning steps, and also as a team how we can have this automation and simplicity connected together all the way to the production layer. As David said, my name is Mohammad Ghodratigohar, but I'm mostly called MG because it is easier than my full complete name, so please feel free to call me MG, and again, stop me if you have any questions. So before jumping all the way to the story that we're going to share and showcasing you the platform that we're going to use for this workshop, let's talk about what are the AI capabilities that we can utilize as a cloud computing resource on Azure. In general, I'm starting with very high level definition. We have 3 pillars that we can talk, how we can enable an AI-based solution. The first one on the left that is coming from Azure Cognitive Services is all about having a model that is already being trained, and I do not need to retrain that model again for the purpose that I'm looking for. For example, let's say I want to have face detection, face verification, or some very well-known NLP analytics on the top of healthcare data set that I'm going to actually showcase you quickly. You do not need to necessarily train the models again, because these models are already trained with huge amount of data. Some of them, those data are annotated with Microsoft experts and being trained on huge amount of compute capacities. So they're ready and they're there for you to just have them as an API call. And through this API call, you can retrieve the outcome and just add that to the application that you're looking for. After having those API-based solutions, that one of them is also healthcare text analytics that I will show you quickly, we can have the knowledge mining on the top. Let's say we have the prescriptions of doctors being handwritten, and we're going to actually digitalize those. So the OCR models that can convert those is already there, and we can have health analytics on the top that you do not necessarily need to retrain those models all again. You can just leverage that for your knowledge mining. Let's have a quick example specifically in healthcare that how these two services can be leveraged before talking about the third pillar, which is Azure Machine Learning and Azure Databricks that we're going to mainly utilize for our custom solution for machine learning. So if you question that, what is the Microsoft healthcare specific services that we can use and how we can use, one of them is called text analytics for healthcare. Let's say you have, again, healthcare data set, some text related to patient information, prescriptions, or some reports about how the treatment or diagnosis journey has been happening for that specific patient. And now you want to have some automated analytics on the top. That service is being ready here, and these models are being trained on huge amount of medical data set. And just quickly show you what you will expect as an outcome. You can see that, for example, this is a healthcare text data, and just calling that service as an API that can be inside your application or web application, wherever you would like to visualize the final outcome, you will see that, well, the symptoms related to a specific disease or the signs, at the same time detecting some medication and the dosage related to that, and linking all these entities are automated for you and visualized here. And even more, we can see some more information about, let's say, examination name that is automatically detected with having some healthcare coding also on the top being added and linked together as those entities that are described and detected by this healthcare text analytics. And then you can just call this solution in whatever production that you would like to have. That can be a web application or maybe within your developer journey, not necessarily having a serving layer on the top. Let's say now you have some images, and here I just downloaded this Kaggle dataset that is a data for X-ray images of chest for normal people and people that have pneumonia disease. And we are going to quickly train the model, not necessarily coding, to just classify these images with just a simple click on train and see the final outcome and performance of the model. If we can have the solution being leveraged, probably even in production, without further coding and also customized solution. So here, for example, I just uploaded this data because for each image data set, I had this specific folder. It automatically detected the labels, and then having the images here, you can see the train button, the green one on the top. We're just clicking on that. If I go to advanced training, I can specify what is my training budget. I can limit the amount that I'm going to pay, since it is pay as you go when you're utilizing cloud services. Or here, I just click on quick training and click on train. Just after waiting for a couple of minutes, it will show me the final performance of the model that I wanted to classify those images. And you can see the precision recall, some of the metrics here appeared. And right now I can do a quick test to make sure the model is performing well, or I can deploy it as an endpoint. So if I go to prediction, you can see the quick test button. If I click on that and browsing a new image from my computer. So first I want to upload a normal picture that doesn't have the disease. So I randomly chose one, and it's showing me the probability of both classes, and with a high probability detected as normal. The same thing for non-normal or pneumonia images. So I selected that again in a different folder, not a normal one, to make sure that also it can classify properly, just as a quick test. And within the same process, selecting the image that I want. And again, it will show me with a high probability that was able to detect that class properly. So you might question that, well, that was no coding solution. I just uploaded the data with having the labels there, and I can do object detection, labeling the object that I'm looking to train the model and detect them later. Then I can just really click. I was able to train this model and also test that as well. Afterwards, Okay. Okay, since I cannot control, sorry, I have to decline because I think I cannot control the screen. Okay, so let's now talk about some other solutions that we are going to make it a little bit more customized. I want to train my models with the code that I'm going to specify, not just necessarily a simple image classification that we did. That's the time that we're going to jump to the third pillar, which is Azure Machine Learning and Azure Databricks, that I will talk about them shortly, and we will see them in the hands-on part of this session today. So what is Azure Machine Learning? Well, Azure Machine Learning is a service on Azure that is basically a platform that we will again see each other quickly. This platform is a collaborative environment that all our data scientists as a team can come to a unified workspace and work on the same project or even multiple projects at the same time to develop their data science journey. So why we need such a platform? First of all, we need a place to put our workload of data science journey there, to have a collaborative environment to write down the codes. And at the same time, one of the main reasons that we are leveraging cloud computing is scalability. So I should be able to, with just a simple click, choose a CPU-based machine or a GPU-based machine to train those models and go further with executing those codes. Not only that, we want to have traceability of the machine learning journey. If I just train a model, later on, there might be model drifting, data drifting happening, and I have to come back to that platform to be able to track who created that model, what code trained that model, what data set was being used, which version of that specific data set was being used, where the data set is coming from, what were the metrics and logs of the model that we trained, which model is in production now, which model is in development stage now. So having this all end-to-end traceability and monitoring process will require us to have a platform that not only can be used for just development journey, regardless of the size of your team, and at the same time for enterprise-based solution that we can leverage. That's one of the main reasons that we're going to talk about Azure Machine Learning. And for this specific demo session, we're going to leverage that. So I want to show you actually the Azure Machine Learning and describe the capabilities a little bit more there, because that would make more sense and you can see the platform. But again, I would like to prepare you for that part with just having a very high level explanation about this platform. So this Azure Machine Learning workspace has main components, as you can see at the center of the slide. I will quickly introduce them. The models, which is a repository that you can register the models that you have trained as a list, and add all the information about that model, for example, the framework that you use to train the model, who trained the model, what data, what code, all being tracked and logged beside the model that has been registered. And from that list, you can choose the model that you want to just deploy with a click that we will see each other shortly. The experiments. Experiments is like a umbrella that can isolate different use cases that you're working together. Right now for this demo, we're going to do 2 use cases to have a predictive analytics. So with having experiments, I can isolate them and log everything for that different project we are working at the same time within the same platform with my team. Pipelines. As you know, one of the most reasons that we have to have our Azure machine learning journey as a pipeline is about having the scalability for different steps. Maybe in my featureization steps or pre-processing, I do not need to necessarily have a GPU. But in training part, I do need a GPU to train that deep learning model. Is there any way that I can distinguish the compute engine that I'm using for pre-processing versus training? Yes, if you define them as a pipeline, and all those steps are steps of your pipeline. And then you can just trigger your pipeline like an API call to have that retraining process on and on again. We will see that shortly. The compute target, we will see that how we can create a compute, how big we can have that compute to scale that up or down, and whether it can be CPU, GPU, or a cluster, which is a combination of machines that can have parallel processing for us. Images. We have heard that sometimes. I used to actually experience that as well. We trained the model in our workstation that can be your personal laptop or PC, and then we pass the pickle file with some metadata and information about the solution to the DevOps team and say that, well, this is the model, or a machine learning engineer, please deploy that in production. And they're gonna come back to me and say that it failed. Our operating system cannot detect some of the libraries needed. That makes sense because the environment that you train the model is different than the operating system or environment of the compute engine that's going to actually host your model in production. So we have to capture that environment as an image container and then ship it within the model to the production. And Azure Machine Learning will capture all of that automatically for us. I talked about deployment and we will see how we can do it. And data stores is a way that we can connect our Azure Machine Learning to different sources to grab the data. That can be a data lake, SQL, Postgres, on and on. And again, we will check each other quickly. So they were high-level definition of Azure Machine Learning, but now I want to have one step down. So what are the three main capabilities to train models in Azure Machine Learning? The first one is automated ML. I see actually someone just questioned about if this workshop will cover AutoML. That's correct. We are going to actually cover that. So in AutoML, I do not want to code. And as you know, as a data scientist, we have to train different algorithms with different hyperparameters. And each algorithm by itself can have different configuration of those hyperparameters. And checking all of those and coming up with a kind of optimized search methodology to come up with the best combination would be challenging and time consuming. Even the featureization part, the pre-processing part. So is there any way that I can automate all these steps without coding? The answer is yes, and it is automated ML that we're going to use today as well. Let's say now I want to have a little bit more flexible solution. Instead of making everything automated, I still want to have my customized solution to define the steps from getting the data to all the way to training and production. But again, I don't want to code. There's a second solution called Designer that you have a visual interface with just drag and drop, as you can see in short video, that you can have all the steps of your machine learning without any coding, and just with clicking on run, all those steps will be executed. Last but not least, if you want to have a fully customized solution that we're going to actually use again as well, is something that you had like Jupyter Notebooks. We have Azure Machine Learning Notebooks here that we will see, or we can also open up Jupyter Notebooks on cloud, but the code will be executed on the compute engine that we have created on Azure Machine Learning. So that was a high-level definition about Azure ML, and we're going to actually see that shortly. But what we are going to enable, what is the story that we have defined, what is the business requirement, and what we are expecting to achieve by the end of this use case. So the first part, we will start with data. As always, the journey starts with data, and we're going to ingest the data to our Azure ecosystem. So what are those data sets? We have admission data coming from different hospitals about some patients coming in. And by the way, all this data is mocked, so there is no personal information. And some of them we mock the label. So regardless of what is the accuracy of the models that we're going to train, it's all about just showcasing how this solution end-to-end works. So we have the admission data set for different hospitals when they arrived, and the location of those hospitals in a separate data set that can be joined based on the location ID or key. And then length of the stay. We have a labeled data that show us what was the length of the stay, how long those patients stayed in the hospital after finishing all the treatment process. With ingesting all of that, we can do some transformation on the top, and we will have a curated data set that can be used for training models. Those created data set by itself can give us descriptive analytics, and having a Power BI dashboard, we will see each other, how we can just utilize those data set and transform it on cloud to do some descriptive analytics. But after machine learning part, that's the portion that we're going to have predictive analytics. So what you're looking for in predictive analytics part, we're going to predict two things. So two separate models. First, we are going to predict what is the wait time of the people coming in to be admitted in different hospitals. And they're going to predict in real time. So streaming data, patients coming in at the same time, and in real time, we are predicting what is the wait time for those hospitals that get admission. And the other side, we do not have a streaming or real-time prediction. We will have batch prediction. Let's say now we have hundreds of patients already in different hospitals, and we just want to predict how much they're going to stay in the hospital. So we do not necessarily need to run this model every second as we do for wait time prediction. So that's a batch prediction that we can have, let's say, on daily basis or weekly basis. So the reason that I'm defining these two to just going to showcase you how we can have batch and real-time prediction all the way from development to production through this journey. This is a high-level solution that we're going to talk about. That's okay if you're not familiar with these services. I'll have a quick intro when we reach each step separately. What we start with data, we're going to choose Azure Data Factory as an ingestion resource to orchestrate my data engineering pipelines, to grab these three data sources that I just talked about. And then we need to store those. So we have a data lake called Azure Data Lake Gen 2 or ADLS Gen 2 that regardless of the structure of data, if it's text, CSV, structured, unstructured, I can have them all and can access controls on the top of those sensitive data sets coming in. And then we can have Azure Machine Learning or Azure Databricks, which is something similar to Azure ML that I can have data engineering for pre-processing parts there. But the main difference is Azure Databricks is running on Spark, and it has clusters that can execute my code running on the Spark and distributed processing. Especially if we have big data to do pre-processing before training, I can use Databricks and connect that to Azure ML. That we're going to showcase that as well. And then we can stream that prediction to show that in a streaming Power BI dashboard to give services to applications or end users. After covering those, the last steps that we will talk about, and I want to quickly have a quick introduction about that, is responsible AI. If you ask how Microsoft is defining responsible AI, well, it has multiple guidelines, and as you can see, the principles here, and they can be categorized as ethics and explainability. So for ethical portion, we have to make sure the model machine learning based solution that we have is accountable for what it's predicting. It should be private, safe and secure. It should be explainable for probably medical audience that they're not necessarily familiar with the black box solution that you have provided. So is there any way that we can provide explainability? Is there any way we can assess the fairness of the model? We don't want to see that the model is biased towards a specific gender, a specific ethnicity, a specific group of ages. So how we can assess that the model is fair and it's not harming anybody, and transparency, so on and so forth. Some of them, there is no technical solution for that. So we have to have an assessment framework to talk about the ethical portions. But sometimes we can develop some technical or code-based solution to, let's say, assess the explainability. Or when we talk about privacy and security, we're going to make sure this solution that we just talked about, from data ingestion to storage, can encrypt the data. We can have networking around to make sure no one can access, if we want, the data set. Or if we can define role-based access controls to define who can access a specific data set. And then all the way to the production layer and production layer for the protection, having the role-based access control to see who can access to the prediction layer, and having that all-to-end journey protected in our machine learning operation. So that was about the slides, and now we have a high-level definition about what we're going to do, what is the story, and what is the demo that we're going to showcase. And I just had a quick high-level introduction about the services that we're going to put beside each other to enable this path that we're going to showcase. But before going to the hands-on part, I would love to pause here. If anyone has any question, I can see the chat, or feel free to unmute. And David, if I missed any question, that would be great if you can notify me.
Yeah, so maybe we could just give it a minute for folks to type in their questions if they have any.
Sure.
And also feel free to ask questions that we've passed already. That's okay. I think the quality of and the value that you get out of this is asking questions that you have on your mind. So don't feel bad about asking any questions, regardless of wherever you are in your journey. These are all welcome questions.
Okay, I see questions. We are going to actually, yes, deploy this solution on Azure, but what I'm doing, instead of making this all Azure centric and again making it just educational session for the services, we're just going to see how we can enable this solution on cloud that can be leveraged through the services that we're going to talk. And also on the top, I will be sharing a little bit of my experience as well to make it more even beneficial for the audience here that you're interested to know how we can enable healthcare solution on Azure or in general in cloud computing. And the other question is about how much is Azure service. So if you're talking about the cost, if I'm not mistaken, well, based on the resources that you use from ingestion, storage, computing, like Azure ML, they have different pricing. So if you type down, for example, Azure Data Lake pricing calculator, it will give you a detailed information about what is the cost of that solution that we're going to enable. And it's all pay as you go, which means if you're not utilizing any compute, you just train a model in 1 hour and the compute will be shut down by itself, you wouldn't necessarily be charged for the time that you're not utilizing any services. And if there is no other questions, I will still keeping the chat box open here. But that would be great if you can go again to Menti, and I would love to know what is your idea about the most challenging step for ML lifecycle in healthcare, and it will help me to see which portion we can dedicate a little bit more time to talk about that and how we can mitigate that challenge based on your opinion that you think that's the most challenging part. So it has 5 stages. So if you guys just go to menti.com again, and I will type the website again here just in case. Oh, the voting is closed. Sorry, I have to open it. I think now you can actually vote. This is menti.com, and this is the code that you can use. Okay, for some reason it is closing the votes. Let me open it again. If it's closing again, that's fine. We can probably skip. Okay, perfect. I see the answers are coming. So right now, the production, okay, the data ingestion is the most challenging. Interesting. The storage, 3.5 out of 5, and all these scores are out of 5. Production 4, I do agree sometimes production is not as easy as we think, but we can certainly talk about it a bit. Again, data ingestion is all the top, and we will actually start right now from data ingestion, especially the data engineering portion, pipelining and automating all those ingestion processes is challenging. Again, in healthcare, we have different data sources, all from on-prem HL7 data sets. Sometimes we need a Firebase solution to get the data, and still data ingestion is on the top. Awesome. So we will talk a little bit more about the data ingestion. And actually, that's the first component of the hands-on part that I'm just going to showcase that shortly. So I will keep this open. You can still keep voting, and we will come back and check it out. But thanks a lot for the inputs. Just for last time checking the questions, I see some more questions just got. I didn't know how MS had something called Fairlearn. Interesting. Yes, actually, that's an open source solution that Microsoft research team is vehemently focusing on, and they have got some really interesting outcome that we're going to showcase. You do not necessarily have to be in Azure to use them. Again, they're in an open source community, but Azure Machine Learning has deep integration with those that can give you nice widgets and collaborations that you can have, and we're going to actually showcase that today as well. Excellent. So there's a slide about Data Factory for streaming. So Data Factory can be used for calling something like, let's say, Event Hub to get the data. But what we are doing, we are not doing the ingestion in an Azure Machine Learning notebook to just mimic the simulation, because we don't have a streaming data use case right now. And it was just shipping the data stream in a notebook to grab the data in streaming analytics that I just showed in architecture, and we will see shortly, to have the final outcome all the way streamed to the Power BI. But yes, an Event Hub is being used, and I will show you. Okay, so let me get back to the portal, and I will come back and see the rest of the questions as well. So I will keep the architect open and also the use case definition, because we will come back to this on and on to make sure where we are in this story. So we are now in the data ingestion part and the storage. And we showcased that Data Factory is a solution that we're going to do the ingestion part. And we just saw that, based on your opinion, data ingestion is one of the most challenging steps in healthcare, in machine learning lifecycle for healthcare. If you want to go to Azure portal, just for some of you that you have never utilized Azure, just simply type portal.azure.com. So if you have already a subscription or a tenant inside, it will ask you to put your username and password, and you will log into the Azure portal, and you will see the resources that you have recently opened. If that's the first time that you're going there, you might necessarily see anything because you haven't opened any resources yet. But anything, if you want to access to, let's say I just talked about Data Factory, I can just simply say, type down Data Factory, and it will show me the service. But I already opened that before, so I have access to that, and I can open it from here as well. Before opening Azure Data Factory, well, this is, okay, let me show you the portal first, and I will come back to the storage. Azure Data Factory is an orchestration tool for our data engineering pipeline. It can be connected actually to multiple data sources, regardless of where they are, on-prem or on cloud, from different cloud providers, from different data lakes and storage accounts within Azure by itself. They can be all grabbed, automated, and scheduled to ingest your data. Let's say sometimes there's no specific solution that how we can do scheduling. There's ingestion coming every day as someone asked, streaming. Or I want to be notified if suddenly an ingestion pipeline fail, it will affect my service that I'm providing right now. So is there any way that I can monitor the performance of those pipelines and notify me through an email, through a text message, that if something failed, I can have an immediate feedback to that? Or let's say I want to have some transformation on fly when I'm doing ingestion. You're grabbing the data from on-prem to the cloud. Can I have some transformation at the same time and then ingest it to the sync place that I want to put the data in? So that's a resource that you can leverage, and I'm keeping this development part of that very simple to just make it more understandable, and at the same time to see how we can leverage those capabilities for this specific demo that I just described that for you. So in Azure Data Factory, if I go to Author, this is the place that I can create my pipeline. You can see in the pipeline, there are 3 dots. If I just click on New Pipeline, it will show me an empty space that I can now, with just drag and drop, without necessarily coding, I can create my ingestion and data engineering pipeline. So what I'm going to do right now, I have, let's say, a data set, length of state. And this is the labeled training data set, but it's on-prem. It can be in a SQL database, Oracle, or just a simple CSV file that I have stored in my driver C. Let me show you actually quickly. So this is my local disk on my computer, and I have length of a state data set as a CSV file residing on my machine. I want to actually ingest that data set through an automated pipeline from my PC to the cloud. So I want to move the data. So I click on move, and we just drag and drop, I can copy the data. It will ask me to what is the source, where the data set is coming from. So I have to define that data set is coming from my computer. So I click on new, and here you can see a list of sources that you can have them as an ingestion source to get the data. I just talked about on-prem or cloud resources, and the one that I'm looking for is a file system that I want to grab data. After clicking on file system, it will ask you to type down the user and path and the path of the CSV file in the compute that I have. I already created that, and I will show you quickly. Just wanted to show you the path. I wanted to showcase that portion. And the same thing for the sync, where I'm going to put the data. I want to put it in a data lake, and I will show you what is data lake and how we can put that there. So the same thing, I define my data lake in the sync. And when I talk about data lake, it's just a storage account on Azure. It is based on Blob, and the second generation is here. I can just click, and it will ask me put down the credentials of the storage that can be safe and secure to get connected to that data lake and move the data from my computer to that data lake. Before moving the data, let's see what is that data lake and how we can define that data lake and how it can be secure as one of the portions of this demo today. So again, if you want to figure out where's the data lake, you can just quickly search a storage account on the top, but I have already opened that here, and this is the storage solution that I'm going to utilize to ingest the data there. In the overview section, we have containers, and if you want to question exactly what is storage account, you can consider this as a disk on your machine. Right now you can create a new folder on your machine, then create another folder inside that folder, and then put some files regardless of the format. That can be CSV, text file, videos, images. That's the same concept here, that you can dump regardless of the structure of the data in your data lake and then categorize those. Is it a raw data coming in you just ingested? Then you transform this raw data and you want to move it to another container called, let's say, curated, or some semi-transformed or semi-curated data set. So what I'm going to do, I want to ingest this data to this storage account. Because it's raw as is, I'm just getting from source to the sink. I'll put it in the raw section. I already created this pipeline before to save the time and not putting some time to just entering the credentials. So I have two ingestion pipelines. The first one is for the wait time prediction that we're going to showcase. We have two data sets. Remember, I showed you in the slide, admission data and location data. So I have two separate component in ingestion pipeline that are coming from a different data lake to the data lake that I just showed you. With just clicking on add trigger, here I can define and schedule. Run this pipeline every day, for example, to have new ingestion coming in. Or just trigger now. If I just click on it right now, it will move all the data to the data lake. The same thing for the other pipeline, which is length of stay. This data is coming actually from my computer to the cloud, and I can show you actually the source. If I open that, you will see me, it has the address of my disk on my compute. And if I test the connection, it should be showing that, well, I have been connected to your machine and connection is successful. So I want to make sure that the data will be moved to the cloud. And the same thing, if I just click on add trigger, it will trigger and run the pipeline again. Let's see what happened before just this demo. I ran these pipelines and I was able to get back to my data lake. I go to raw. And based on the date I ran it before, we can specify, let's say I'm running this pipeline today, so I want to structure the folders based on today's date, but it can be specified and customized based on your architecture. And you can see all these three data set through the pipelines that I just showed you are already being created here. Let's say length of stay. You can see that these two were actually in my computer. But right now they're on cloud, and then I can access that through Azure Machine Learning or Azure Databricks. Talking about security, how we can define who will have access to this data set. I think I saw that also in the chat about PHI data. Some of them, they have some personal information about the patient, so we have to be cautious about who can access those. So with clicking on any of them, I can just define manage access control, ACL or access control list. And here I can decide who can read this data, who can write and execute, or who cannot actually access to this data. And if I want to add a new person, let's say MG is already added, my name is here because I created and I have full access to these files. Adding principal, I can search the name of anyone that I want from the team that they have the subscription, access to the subscription of my Azure. I can choose them, select them all, and define again the access level. So before finishing the data ingestion and the storage part and go further, again, I want to pause here to see if anyone has any question about data factory, about the ingestion pipelines and the way that we define the data lake, the access control. Please feel free to add, and I'm seeing that there are some questions being added here. Yes, so we have a question about compliances and PHI scrubbing as a challenge for data ingestion. That's totally correct. So there are some solutions. One of them, actually, I think I mentioned that here. Presidio, it's a kind of solution, again, developed by Microsoft, and you can leverage that, which is an ML-based solution that can detect the PHI information from your data set and detect those, and they can be singled out or selected to make sure they will be scrubbed. Also, there are some open source libraries that you can leverage to have a scrubbing solution for your PHI information. Or the text analytics that I just showed you quickly, that we were able to detect the dosage of drugs and making that connected to a specific disease. That text analytics also have the capability of detecting those PHI information. There's a question. So how would Azure benefit as cloud computing compared to AWS, Google Cloud? Well, that's a very high level question. for each specific resource that we just touched, well, there are some other cloud providers that they have same solution, let's say for storage, for machine learning part, for production layer, and they do have some healthcare oriented capabilities just related for machine learning management lifecycle. I would say probably the differences we can compare later on regarding some very detailed capabilities, pricing. I don't have anything specific to compare that right now, but if you're interested to know the specific details of that, if you just type Microsoft Docs, and in the Microsoft Docs, just type, let's say, Azure Machine Learning, then you can compare that, all the details, or even the pricing calculator that I just shared with you, with, let's say, another service within another cloud provider. What is the difference between admission and location pipeline? Well, the location and admission, both of them are coming from a different data lake to another data lake. And I specified those of them in parallel. That's a good question. Let me show that again. So here I have specified them in different copy activities because they're separate files from separate folders, and I'm moving them to the data lake. And I didn't connect them together because I want to run them in parallel and they're not sequential. So when I put the drag and drop box like this and trigger the pipeline, they both on parallel will be shipped to the data lake. And I think we covered the questions, but if please keep asking, I will pause and come back to the question. All right, so now we have the data set. This is the time to start our machine learning part. So now we can talk about Azure Machine Learning and later on the Azure Databricks in preparation and training. So how can I access to Azure Machine Learning? Again, in your Azure portal, you can just type Azure Machine Learning to find it out, which you can see this logo, but I have already opened that before. So I just click on my Azure Machine Learning service, launch the studio. This is the platform we just talked about all those components, about compute, image, models, all the way to train the models, automated ML that we're going to touch right now. They're all being here as a collaborative environment that we can utilize and develop those two predictive analytics that we just talked about. I will again have a quick introduction about those capabilities, but I would love to be more deep when we're going to touch them for the hands-on part. Before starting the AutoML part, which I'm going to use for the specific wait time prediction and also the length of stay prediction, we need to make sure that our Azure Machine Learning can access to the data. And second thing, we have a compute engine created for executing our codes. So what I will do, I will go to the data stores. That's the place that I can make connection to my data sources from Azure ML. So the first question is, I want to do the length of state prediction. Where is that data? Let's check it out. So I came to my data lake, I came to raw 2021 and based on the date, and I have the location data in location folder, and that's here. And also I have the length of state, which is the first predictive model that I'm going to create, which is here, and I have the CSV file already being uploaded. So how can I connect to this from my Azure Machine Learning? So if I come back to the data stores in Azure Machine Learning, that's the way that I can create a pointer, a connector to a data source that I'm going to use to train model. So I click on new, it will ask me that where is that data that you're going to access? That can be, again, as I mentioned, data lake, SQL database, Postgres, or just a blob or a file share. Right now I'm going to access to a storage, and it will ask me to put some credentials. Again, just saving the time. I already did that before. And you can see after clicking on create, it will show me this data source that I created, and that's here. So I'm connected to this data lake, the same name that we have here, and to the raw container because my length of state data is inside raw. That's why you will see the raw name added beside this. And if I click on that, it will tell me more information about who created that connection, what time it was created, what is the type, and what is the path or the URL to connect to that data store. So this is going to help us in traceability. And when I'm going to write down my code to train models, I do not need to add the credentials of my data store to connect to that data store and grab the data. It is already being secure here and connected. Now I am connected to raw container. Now I want to connect to that CSV file. So I go to dataset on the top if you follow my pointer. Here I can define the length of state data, which is a CSV file, from the data store we created. So I click on create a data set. I can upload it from my machine if I choose the first option, or from a data store. I just created a data store which connected to data lake, so I want to use that. It will ask me to put a name, test123, and it is tabular or a file. Click on next, and it will ask me what data store you want to use to connect the data, to grab the data. Remember, we just created this. That's a data lake in raw container. So if I click on that, I will be able to see all the folders and files that I had in data lake. Now I can see them in Azure Machine Learning. And here I can just simply go to length of a state, click on length of a state, and save, and that's it. Now we have created the data set up to its level of a file to make me able to just grab it when I'm coding Azure ML and execute my training code or transformation. So with clicking on next and define the schema, as I did it before, again, to just save the time, it is already created, length of a stay. And one of the nice feature is, as a data scientist, we are always curious to know some statistics results of the data set, the distribution, the mean, probably the quartile range within a box plot, and having some statistics result to get to know what is the distribution of my data set. If you go to explore of the data set that you created, you will see that all those analytics that you're curious about is already being created for you. So that's a preview of my data set that I'm going to show you about length of a stay. I have some blood test results and some medical assessment for a specific patient, the gender, about the diabetes, the glucose level, depression, hemotrachec, and all the way to the last column, which is my label that I know how long they stayed within that hospital. But if I click on profile, it will show me that the statistical result that I just talked about it. And here quickly, there's a nice distribution plot. Some of them are histogram that show you how the data is distributed within a specific feature, and some other information, mean, max, so on and so forth. So the first part is done. The data ingestion and then connecting my Azure ML to data set is all successful. There's just one step left, creating a compute that you're going to actually use as compute for running AutoML or writing down any code we want. So if I go all the way to the compute, you can see that this is the place I can create new compute based on my requirements. Let's say click on new. I want to create a new compute right now. Again, it is just asking me to put a name and then the location, kind of the center is the closest location to me. And here you can choose whether you want to have a GPU compute or a CPU compute. And if you see all options that you can use as a compute, you can see that the cost, as someone asked, you can also have a quick overview of how much it's going to cost based on your requirement. And each machine by itself had different number of cores, gigabyte of RAM, about the storage. Some of them are general purpose, some of them are memory optimized or compute optimized, and all the way I can go to GPU-based machines as well. And as you can see, some of them can be really heavy and powerful. So clicking on any of them and then just click on create, you will see the created compute here as a list of compute engines that you have. I already created two, MG01, MG02, and both of them are running, which means that I can shut them down when you want, anytime you want, and run them again. Or if you want to have actually a cluster, which is a multiple combination of different machines connected together to execute your code, I can go to compute clusters. And again, I created one. This machine has up to 5 nodes. It means that consider right now your laptop or PC that you're joining this demo, you can have 5 of your machines connected together to execute your code in parallel. That we're going to actually do that for the prediction. If I have huge amount of data and I want to do batch prediction, I can actually do the prediction utilizing that cluster. So someone just mentioned that they cannot hear my sound. Please let me know if anyone can hear me. Okay, so Nicole, I hope you're okay. Perfect. Thank you so much. So I have already created a compute cluster, and the nice feature about this is, again, coming to the cost portion that we had the question, if I'm not using all the capabilities and capacity of this compute, it will auto scale by itself, not necessarily launching 5 machines for you. If it's needed, it will be launched. And when you're not using that based on after, let's say, 100 seconds, it will all shut down by itself. That's why I have 0 active runs to save the cost. But when I launch AutoML, I want to use this compute to parallelize my automated machine learning journey to have multiple models with multiple hyperparameters running at the same time. So now we know that the compute, how we can create it. We connected the data set. Someone might ask, do I need to be in Azure Machine Learning to write down my codes? The answer is no. You do not need to necessarily open a notebook here to write down your Python code. You can just open a Jupyter Notebook with just clicking on Jupyter Notebook. It will launch down a notebook for me, and this is one of the most familiar tool for us. Some of you might be more comfortable to still have the Jupyter Notebook environment to write down your code. That's the same thing, but your code will be executed on the machine that we just created. If you want to have VS Code, which is an IDE that I have on my machine, I can just click on it, write down code on my laptop, not necessarily even going to the Azure portal, but just the engine part will be running on cloud, not my laptop. Or any IDE, if you're using, let's say, PyChart, there's a Python SDK that you can call your Azure Machine Learning, leverage the compute here, but you all the way code in the environment that you're already familiar with that. And you can also open terminal that is running on Ubuntu machine and even R Studio, because Azure ML support also R as well. So let's go to the AutoML, and that's the place we want to train the first model, which is a regression to predict length of stay for patients that they're already in hospital. So let me go back to just the use case definition again. Now we are here, and please note that that's a batch prediction. It's not a streaming. We want to do prediction, let's say every week based on all new patients that we have already admitted in hospitals, or every day. So that's not on a streaming. For creating an automated ML, I just click on plus sign here. This is the first thing that it's going to ask me. What is the data set that you want to use to train the model? That was the reason first we defined the data set, and then I came to actually Azure Machine Learning. So here I can see different data set I defined before, but we want to predict length of stay. So this is the data that I'm going to choose and click on next. And that's actually a labeled data set. And I see questions. I'll come back to the question shortly, but just I will finish this part and then I'll certainly answer. So here is asking me that define experiment. Remember I told you in the slide that experiment is a way that you can define a specific use case and then retrain the models again, all under the umbrella of that experiment. I can say, yes, I want to define experiment, type it length of stay. I already created before, I think so. And if I click, yes, it is already created. So I'm going to predict length of stay, and I have defined everything that I want to log under length of stay experiment. It will ask me what is the target column you want to predict. So the length of stay, that's the label that I'm going to predict. And here again, it is asking me what is the compute machine that you want to train the models. And it's asking me compute. You might know the answer why. Sorry, it is asking cluster. And the reason is AutoML will train multiple models with multiple hyperparameters configurations. So that definitely makes more sense if we can have a cluster of machines in parallel. Each of them run different models at the same time to save the time for me and be more efficient. That's why we already created the compute cluster before. I will just select it. Even if you haven't created before, you can just click here and it will open the compute portion for you to let you create a new one. We just saw that. And if I click on next, this is, I think, also someone question. If I missed a question, probably I can just describe that here again. What kind of task AutoML support? So we can support classification as of today again, but we will see more, regression, and also time series forecasting. I want to do regression, so I will click regression, and here we can see some additional configurations. Here are some lists of the models that AutoML will utilize. Let's say I know that I want to have KNN as a part of algorithm to be selected and tested to see how it's going to perform for my regression model. So I can just select it and it will be blocked. So AutoML wouldn't necessarily utilize it. Or if you want to have some exist criterion, let's say that I want to have a timeout for my training process Or concurrency. Remember I told you we want to have parallel processing using that compute? Because I have 5 nodes that I selected in my compute cluster when I was creating, so the max concur that I have is 5, but you can certainly change it. What is the primary metric to assess my model when I'm training? Because it's regression, it is giving me the regression metrics that I have. So after selecting those and clicking on start, it will start training the models. That might take a couple of minutes or even more based on the size of the data set and number of the models and the training hours that you have specified, if you specified any timer. So for saving the time, I clicked on create and they're already being stored, and also I will show you quickly. So I click on cancel. And if I go to AutoML again, this is the list of AutoML run that I executed before, within the same process that I just showed you. If I click on length of stay, that's the one I created before. It will open up a tab with all details about this AutoML. Who created that? How much was the duration? So it took me almost 40 minutes. And what is the run ID that I can specify this experiment and run among others? What was the task type, the metrics that I use, and experiment name? Let's dig in a little bit more about the details. So I mentioned that AutoML, we do feature pre-processing by itself as well, not necessarily doing all by yourself. So you can see that it's checked as a guardrail that if I'm missing any feature in my data set, so it passed because I didn't have any missed values in my features. Or high cardinality. If some of the features are highly correlated together, there is no reason to have redundancy and have more dimensionality if it's not needed, and the information that we can have from one feature is already existing from another feature. So it already passed as well, and I didn't have cardinality. If I go to the models, that's the part we can see the list of all models that AutoML trained. I have 2 pages here. You can see different models with different event featureization. Let's say we have Microsoft Scalar before having the light GBM. They have, again, just regardless of the accuracy, because some of the data set is mocked and there is no specific pattern, just show you the flow and how it works. It will show you the primary metric that you chose to see the performance of the model, the submitted time, and some more information about the hyperparameters that what has been chosen for that. And you can see, for example, this is for the scikit-learn package that I use for training a light GBM as a regression. You can see that the best model was kind of a stack of different models assembled, and you can see the outcome, and it created the explainability automatically for the best model. For the last portion of the demo, we will just dedicate that to check the explainability, but just for a quick overview as of now, if I click on explanation, it will show me multiple explanations being created for me and visualized in the dashboard. It will show me the individual feature importance, the overall model performance, how it predicted, that I can explore each individual data set, and I can see aggregated feature importance. Let's say how much gender was important in general for predicting the length of a stay, or how much sodium level was important, or any other columns that I had there. And if I just change these top number features, it will show me different components. I'll come back to that, and we will have just a specific session for this part, because to me, this is a very interesting and very useful component, especially in healthcare scenario. Just quickly show you, and we'll come back to that quickly. So let's get back to the details part. This is the detail for the best model that I have. And we just checked the explanation part. If I click on model, it will show me some more information about the model. If I click on other metrics, it will showcase me all different metrics for the best model that AutoML trained and get back to me. The data transformation step, if I click on that, that's a preview feature. It will show me kind of a visualized map of how the pre-processing was done on the model automatically and all the way to that stack solution that we had as the final model. And the logs. If I click on the logs, it will show me some very detailed logs about the driver node of that cluster that ran and executed this AutoML journey. And if I go to the output, we will see that we have the model as a pickle file being created. I can just simply download it. Not only just model, if you remember in the slides, I mentioned that just shipping the model doesn't mean that it's going to work in production. you have to also capture the environment that you use to train the model. That's how AutoML captured the Conda environment for me. If I click on that, you can see all the libraries that was being used to train that model using Azure AutoML has been captured here. So I just simply use this YAML file that define my environment beside my model to go all the way to production. But the question is, for loading that model and doing the prediction, we need a code. So how we load the model and how we do the prediction, which is called a scoring. There's a scoring Python file also created for me that show you how you can load the model, put the input and run and get the output as a JSON file being retrieved back for the prediction layer. This is what I will use as well when I will deploy the model. So before going to deployment part and to see how we can deploy it, I want to pause here if you have any questions, and I will be checking the chat to see if there's any question. There's a question, Azure can provide module for ML algorithms. Is it possible to create our own ML algorithm, for example, customize CNN? Absolutely, and that was exactly the next portion I want to talk about. Let's say, yes, I don't want to use AutoML. I want to have all customized solutions. So I just show you can launch Jupyter Notebooks or any IDE you want that can be connected to Azure ML. But even here, if I go to Notebooks, it will show me several folders that based on the name of each different team members that they're using the same platform, they will have their own folder. So I'm the only person using this platform, and that's why there's just only one folder for me with my name. And under my name, you can see different folder I specified and different Python codes and notebooks that I executed here. To create one, I just click on add, create a new file. I can say if this is a Python notebook or bash text and just give it a name, test123, and click on create. And it will launch actually a notebook for me that, as you can see, it is connected to the compute we created and name it as MG, and it is running, but I can pause it here and I can access to the terminal of that compute in Ubuntu just with clicking on terminal icon here. And I'm ready to just write down my Python code and come into your point, Marcia. I think you asked a question. Yes, you can write down any custom machine learning code, let's say, as you said, CNN, to write down here. The great news is, as you can see, I'm using the kernel Python 3.6 and it is added Azure ML. What does that mean? Well, when you create a compute in Azure ML, the image that has been used to run this virtual machine has already installed some data science libraries like TensorFlow, Keras, Scikit-learn. So all main and majority component of the data science packages is already being configured. So you do not need to put your time to install all those libraries doing pip install for separate packages. And sometimes we have faced up with the issue of having incompatibility between different libraries. So having that chance of configuration automated for me will save my time, and I do not need to do those pip installs again. And again, when I have all the pipelines, all the packages, I can choose any code that I want and import them. Right now, I'm just executing a simple print to just show you how it can be used and customized with any code that you want as you question in Azure ML, not necessarily going all the way to AutoML. We have a question from Linda. Is it more common for data preprocessing to be done out of Azure ML? That's a good question. Azure ML is a complete platform. It's not just for training. And as you can see right now, I'm connected to my data set and I can do any kind of pre-processing and transformation that I want using AutoML or using our custom code. But I mentioned that you can actually leverage some other services we are going to do for the second model as well to do the pre-processing part. Let's say I'm dealing with terabyte of data and I would love to use a service that has already, let's say, a Spark enabled, that I can create a compute engine. Spark is already there, pre-process, and when I do the training part, then I can call Azure ML to train and do everything, or use AutoML and then register the models. This is exactly what we're going to do when we use Databricks for pre-processing and then using Azure Machine Learning for training, or even not necessarily training, to having a management platform to log everything and then do the deployment. So the short answer is yes, it is possible based on your requirement, based on the size of the data set, and based on the familiarity of your knowledge level with your team. If you're already using Azure ML, so you can certainly already use it for transformation. Or if there's any other tool that you're using and you're comfortable with that for transformation, you can still keep that and just import the Python SDK of Azure ML. We're going to show that as well to use Azure ML. The scoring created automatically by AutoML. Yes. So the score.py that show us how we can load the model and do the prediction was automatically created by AutoML. You can custom that and write down by yourself as well. But if you don't, you can just deploy the model immediately, having the scoring.py and also the pickle model and also the environment YAML file that we just show. It was registering the libraries of conda dependencies we had there. So they're all being created automated. You can just launch them and deploy the model. Again, if there's any other question, please keep posting them. I'll come back to the question chat shortly as well. So the automated ML retrieved back the best model, and it was able to register the model. And if I go to models, that's a list of the models that I have. They are registered. Some of them, they are not deployed yet. Some of them are just simply registered. Some of them, they're actually deployed and they're serving the end users in production layer. So you can consider the model list here as a component in Azure ML as a repository to enable you the traceability and log all the steps about that specific model. For example, for length of stay, I trained multiple models using AutoML or a custom code, and you can see that it was able to detect these are the same models but with different versions. That's how I can have retraining process to detect the best version and deploy to production. Let's just click in one of them. So it will give me some information about the framework. If I just click on Run ID, it will open up Azure AutoML because I use AutoML to create this model. So I can trace it and get back all the way to the steps that we trained the model. If I go to versions, it will show me different versions of this model, the artifacts that can be your pickle files that I can just download them all or keep it here to just deploy. And if I have productionize this model, it will show me the endpoint, which is a URL that you can call this as an API to let your model that you have trained to do the prediction for length of stay. And the explanation that we're going to come back and fairness as well. So now let's say I want to deploy this model. That's the best model that I have and I want to deploy to make some predictions. If I click on deploy, it will ask me if you want to deploy in the real time or to a web service. If I click on web service, I can have different type. I can deploy the model in Kubernetes or in a container. And then this is the place also someone asked this question, like I was saying, you asked about the scoring. That's the place that I can have the scoring Python code to just load it here and tell that this is the way that I do the prediction when I want to deploy the model. And this is that YAML file that show what kind of packages and libraries I need to be installed when I want to deploy this model in a production machine. And you can provide a token to make sure you know who can access to this end user service to call that API and retrieve back the results. But the main question is, we are going to do batch prediction. If we were doing wait time that we're going to actually start that shortly, yes, we need a kind of web-based API to call that URL, put the input as a JSON file, and retrieve the prediction real time, and do that all again based on streaming data coming in. But we are doing the batch prediction right now. We want to run this model, let's say, every week. So I do not necessarily need to have a machine running 24/7 as a deployed engine and listening that if someone will call that API and do the prediction. So what we're going to do, we are going to do the batch prediction. And that batch prediction is just all about having a pipeline, executing that every week, let's say, and it can be running on Azure Machine Learning. And I want to parallelize that batch prediction because let's say now we don't have big data for the demo. Let's say we have huge amount of demo for the data for the patients that we have all for the last week. And I want to parallelize this prediction, having 5 machines do the prediction for these patients that we have at the same time and merge the final outcome of all predictions as a CSV file that then I can use it for dashboarding and having some final end user analytics. So for having the batch prediction, I created a notebook. And if I go to the notebook section, I have parallel run configuration, Python code, which is actually a notebook that can be again a Jupyter notebook or any IDE you want. So what I'm doing here, I want to have the length of a stay model just be trained using Azure AutoML. And then grab it to do the prediction through a parallel processing for a batch prediction. So what I'm doing, I'm connecting to an experiment. Remember we titled that length of stay experiment, which we created an experiment. And it is asking me that what is the AutoML run ID that you actually ran the code. And if you remember, I opened the AutoML. Let me see if I can open a new tab. It is under this. Let me see if I can open it. Okay, I can open it probably here. So if we ran the AutoML run, you can see that each run by itself has an ID. And the one that I was for wait time prediction is here. So I just simply copied that and came back to my notebook. And here's the place that I put that ID. So it is telling me that go to that AutoML one that you train the models and then grab the best model for me. So fitted model, I have it here. And then I have registered the model. That's why we saw that length of stay model when we went to the model section. So I have the model ready. And what I'm going to do, I want to create a Python file. I executed this cell. That's why I have the run Python here, run.py. And what does it do? This is the way that I'm telling that how you can do prediction. It's a scoring. I'm telling that load the model, that length of stay, and then do the prediction based on the new input coming in. And that input is a batch. Remember, we're going to have parallel processing. Each partition of the data will go to different machines in parallel, do the prediction, and then merge the final outcome. So if I come down, then I want to run a module in Azure Machine Learning called parallel run config. And I'm telling that I want to append all the prediction based on different machines and put all predictions in a CSV file within this name. And where is the scoring file? That's the run.py we just created on the top. And that's it. I defined it as a pipeline. And then I'm calling that this is the pipeline that I'm going to have. And this pipeline just have one step. And one step is doing just prediction in parallel. And that's it. I submit it. I chose it a name. And when I ran it, again, it might take a couple of minutes based on the size of the data set to save the time I ran it before the demo. It gave me a link that connects to the pipeline. So if I click on this link, it will load the Azure Machine Learning portal again for me. And you can see it has created a nice kind of diagram or architecture to show you the flow of the pipeline we just created for having the batch prediction. You can see that our pipeline just have two steps. We are getting length of stay, the data set we created together, and then we are doing the batch prediction based on the code we just defined, and it ran successfully. If I go to the output and logs, if I go to the logs, okay, I have to click on the batch prediction before I go in. So I want to know the logs of the batch prediction to make sure they ran successfully. So I click on these steps again, and here it will show me the outputs and logs. I can maximize the panel a bit. And the driver log is telling me all they ran successful, and also show me that the place that actually this prediction outcome is stored. You might question that now where's the prediction outcome? I can define specific storage data lake that, hey, when you're done with prediction, put the final outcome in a specific location. If you do not define any location, Azure Machine Learning will store that prediction in a default storage. So the question is, what is default storage? When you create Azure Machine Learning on backend, Azure Machine Learning comes with a storage. The reason is right now we have codes. I showed you all those notebooks. I showed you all this information about logs. So these are information. And we need to have a storage that Azure ML can use to put all these logs and store your codes, your logs, and everything there. So there's a default storage being created. And that was the place, because I didn't select the prediction final outcome location, it was already created in my default storage. And we're going to check it out, the final outcome quickly. So if I go to my Azure portal, and if I click on Azure Machine Learning, if I go to, okay, without going to the portal, you will see that there's a storage being created using the machine learning portal that we have. So I click on the storage. And based on the path that I saw in the log, I know where the prediction is actually being located. So I click on here, Azure ML. And these are different runs of AutoML. And as you can see, all the legs, all the logs, and all the information being stored here. This is the run ID for my batch prediction. If I click on that, you can see there's a prediction folder created, and this is the name we chose when we wanted to specify the parallel run configuration. And we said that merge all the prediction as an outcome and put them on a CSV file. And if I click on that, if the CSV file is not huge, with clicking on edit, it will show you the predicted outcome of length of stay based on days for all the patients. I think we have 1,000 rows, which was much faster because we have parallel processing to execute. And now we have the data, we can connect our Power API to this storage and visualize some final outcome for end users. Let's say here's an example that you can see as a Power BI dashboard that can show us to have more insights about the operation inside the hospital. We can see the discharge date based on the prediction for different patients. And we know that, for example, for this specific date, we have more discharge based on the length of stay prediction, or not necessarily predictive. We have descriptive analytics from the data set that we use for training. And we can see the average level of results or count of encounter based on readable tumor and some other let me actually maximize some other information coming from that predicted outcome, and it can give you a hint what would be your total capacity, which can be certainly helpful. So before I continue, let's come back and just cover what we have discussed. We started all the way from data ingestion. We did the transformation stuff and training all using AutoML, but again, to your question, that can be customized through any code that you want. And then we trained a model. We had the batch prediction to use a cluster to have parallel processing, and final outcome was visualized in the dashboard. Before going to wait time prediction, which is going to be the interesting part, and we're going to cover explainability and fairness there, I would like to quickly pause here and to see if you have any questions, and I will open up the chat. So please, if you have any questions from all the steps we covered, please feel free to share. Thank you. And I'm reading the question just in case if I missed any questions. I think I answered the question, Hossein, not mistaken, but just in case, yes, all those components are automatically created using AutoML, but again, they can be customized as well. Okay, I think I covered the previous question. Again, if there's anything, please feel free to ask. Otherwise, we can just continue with the next step. All right, again, the chat part is open. Please feel free to ask. No problem with saying thank you. Feel free to ask any question that you have, and I will come back to the chat portal and make sure that I'm not missing any question. But if I miss any question, please feel free to add it again here. I'm scrolling up to make sure I didn't miss anything. So now we do have some insights that how long the patients will stay in a hospital. But that would be great if we can have a little bit more advanced analytics to see if we can have some real-time prediction using some streaming data coming in and have that predicted value as a final outcome, all end-to-end visualized in the dashboard. So for doing so, that's a little bit more complicated aspect of deployment, because we should have a service to listen 24/7 to make sure that that service which is in production is ready to do the prediction whenever we want to predict that continuous wait time category. So first of all, again, we need to define the data. We already ingested the data, and we have to do the training phase of that for this specific model that we're going to create. So let me get back all the way to Azure ML, and let's see how we can train the model for this one. Someone asked that, can we use some other services for pre-processing and then using Azure ML for training? The answer is yes, and I want to actually use this portion of the demo as an excuse to showcase you also this capability that you can have, that not only you can use Azure Machine Learning inside the platform, at the same time you can leverage this service even if you're outside the platform. So the other service right now I'm going to do for pre-processing, considering just the fact that if, for example, the data is huge and we are going to run on Spark, again, I come to Portal, and you can just type Azure Databricks if you do not see it here. Again, I opened that before, so I can just simply click on that, and it will launch a workspace for me. Since Azure Databricks might be a new service for some people here, I will have a very quick introduction about that, and we will start to see how can I connect to Azure ML to have this joined solution for my second model. So Azure Databricks, again, is a collaborative workspace and platform, something similar that we have in Azure ML. So if I click on workspace, the same thing that you saw in Azure ML, that we have notebooks for each user, and you saw my name, and under my name, I had Python notebooks there. The same thing that you can have here. Again, I'm the only person in this portal, that's why you don't see anybody here. But this platform is a collaborative environment, not just for data engineering and transformation, but also for training as well. The main advantage of having Azure Databricks is this platform is running on Apache Spark. And if I go to the compute section, you can see I can create cluster, the same concept that we have in Azure ML. So as you know, clusters are the combination and collection of multiple machines that can distribute my workload using a Spark over that cluster. And I can here define huge amount of cluster based on the number of the nodes that I want. So the same thing we saw in Azure Machine Learning, you can have GPU or CPU, and here you can define the maximum number of, let's say, nodes that you want to have, and they will be auto-scaled. So if your code is not heavy, it wouldn't necessarily launch 20 nodes. Or if your code is heavy, it will launch all those nodes, do the parallel processing, and shut down the external nodes to save the cost and be efficient in your workload. So after creating a compute using a cluster here, you will see the list of created cluster here as well. It will take a couple of minutes, sometimes even seconds, but sometimes even more, to launch the cluster and show a green sign to let you know that it's ready, that you can use it. But because we are not going to train the model and wait for that again, so I'm not going to execute the code. I just want to have a walkthrough about how we can enable that code. So here, what I want to do, I want to do some pre-processing and also training the model, but I want to still have the capability of automated AutoML because it was really the time saving and efficient for me. But the question is, now I'm in Databricks, I'm doing pre-processing, and even I want to use a Spark to distribute even the training part if I'm training a model on huge amount of data. But I'm no longer in Azure ML. So is there any way that I can still be here, leverage these big data and Spark capabilities, but at the same time using Azure AutoML to utilize that great service that we have there, and also log and track everything and deploy the model later on using, let's say, the deploy button that I just showed you in the portal. This is exactly what we're going to do, and the short answer is yes, it is possible. So what I did, I created a notebook. The way that you can create is if you click on workspace, right click on here under your name, click on create. I want to create a notebook, very similar to Azure Machine Learning. I can choose the name and the languages that are supported using them and leveraging a Spark through the APIs is Python, Scala, SQL, and R. So I have chosen Python and I rename it as training. And then that was the notebook that I had, and I started to code. Also, if I'm coding that with a group, everybody can comes in, we can code together real time at the same time. Anyone can put comments here to see how the portion is going on and how we can collaborate to develop the code. So I did just pip install to install the libraries that I need to connect my Azure ML and use AutoML. I'm connecting to the ADLS Gen 2. Why? Because all those wait time data set, the admission data set, the location data set we saw in Azure Data Factory is already loaded in the data lake, and we saw that it was in raw container. So I'm connecting to that, putting some credentials there. And then I am using Spark SQL to select just the columns that I want to predict that wait time. And just show you a quick overview, we have the specific title of the section of the hospital, the attending provider type, the gender of the patient, who is the primary payer, the age of that specific patient, service line, arrival time, diagnosis, and location. As you can see, location is the hospital, but I have another data set called location, and based on the location ID, I can grab the location name. So when I visualize that, it will be more appealing. So any transformation that you want to do, regardless of your requirement, any pre-processing, you can all do the same here as well. But right now you're utilizing the Spark engine running on Databricks. Even not necessarily predicting model, before even prediction, when you're doing any descriptive analytics, you can still connect your Power BI and have some information and visualization before even prediction. Just quickly show you an example. Because again, my data is in data lake, in Power BI, I can just simply click on get data, click on more. And then here, I can have all different options as a data source in Power BI that I can grab the data to visualize them. I click on that. I think it's gonna take a while to open because I'm opening multiple Power BI dashboards. But when you click on get data, it will give you the chance that you can search data lake. So that's simply what I did. I searched data lake. I put the credentials of my data lake that I had, the location and admission data in raw container that I just showed you. And I was able to actually grab the information and do some visualization on the top. And if so finally it opened. And in get data, I can choose data lake. And you can see that Azure Data Lake is here. That's exactly what I did to connect. And then you can use any Power BI capabilities if you're comfortable and familiar with that. Let's say I'm curious to know how the wait time is changing based on a specific gender for that specific admitting provider. And if I click on any of those, it will interactively change the rest of the dashboard based on choosing, let's say, the service line or choosing the location of that specific hospitals and the average wait time of the hospitals that I can have and visualize them. It's running a little bit slow because I'm opening, I think, multiple pages, but clicking any of them will change all different plots here related to that specific hospital. Let's say I want to click on that hospital, and as you can see, the plot is changing and all these information are changing based on that specific hospital I created. So this is our descriptive analytics portion. Let's put one step further and start the training portion. So now I have some pre-processing steps happening, and I want to again use AutoML to do featureization, all automated. I'm connecting to the Azure ML. That's the first thing that I need to do. This is the place that I'm actually making that Azure connection to Azure ML. It is loading a JSON file, and in JSON file, there are some credential information that has the name of my Azure ML workspace, the subscription ID, the resource group. These are the information that can let Databricks know what is the Azure ML workspace that I want to connect. And that is inside the JSON file. I'm connecting to that workspace, and now I have WS that represent my Azure ML. So using that, I can do whatever I want in Azure ML as we did in Databricks. Remember, we created a compute, we created a data set. You can use all of them again, but you do not need to necessarily go to portal in UI of Azure ML and do it by manually. You can do them all here. This is exactly what we're doing. So I'm specifying an experiment because this is not length of state prediction. That's a separate use case. I want to have the wait time prediction. So I'm choosing a name for the experiment and some information about the workspace that I got connected and the data set that I just grabbed from data lake. I can do any pre-processing that I want, train and test split, and here I can able to create a data set. Now instead of using Azure ML UI, I created using the Python SDK that I connected to Azure ML to define the train and test CSV files. And here's the step that I want to do AutoML using the Databricks as an engine, but using the capability of AutoML of Azure ML, even if I'm not inside Azure ML. What I'm doing, I'm just setting the Azure AutoML configurations. I'm saying that, well, this is the iteration timeout. This is the primary metric that I want to have for training the model that would like to do the wait time prediction. Well, it's clear that's a regression, and the target label or the column that I want to do prediction is the wait time. So I need to configure all of them. But the nice thing here is Spark is added as a part of my AutoML. We didn't have it when we were in Azure AutoML. The reason is I came to Databricks to utilize a Spark as a distributed, powerful engine. So I'm telling Azure AutoML that still I want to have Azure ML capabilities, but running this Azure AutoML over Spark. That's why I have defined the engine. So it will be running on Databricks, but using Azure AutoML. And that's it. I just ran it and I retrieved back the best model and I was able to register that model. As you saw, I didn't touch Azure ML at all. I did all these steps and I retrieved back the best model, but using Databricks, and I registered that in Azure ML, again using Databricks Notebook. So let's get to Azure ML and see what is happening there. So if I go back to my Azure ML, and again, I'm checking the questions. If you have any questions, please feel free to share. So let me get back to my Azure Machine Learning portal to see what happened when we trained the model in Databricks. If I open up the Azure portal again and launch the studio, so if the code was running successfully and Databricks was able to call Azure AutoML to train the model, I should be able to see that as a run. So if I go to AutoML, we will see that, yes, there is an experiment named length of stay. Sorry, it's the wait time prediction. This is what we define. And also it ran successfully and it completed. So I click on run AT, the same thing. All the information that we got for the length of stay prediction, now we have for this regression model that you're going to predict the wait time. Just checking the guardrails, it done some checking the cardinality again, the missing features, we described them, and some models. I specified less number of models because I wanted to just quickly test the solution and do not wait for training lots of different models. That's why we have less models here. And as you can see, LightGBM was the best model to predict the wait time. We did all of that before without coming to Azure Machine Learning Portal and without doing anything manually. So I use Databricks, and it doesn't mean Databricks is the only solution. Again, because I saw that some people asked this as well, not just Databricks, any other IDE, you can do similar concept, use the Python SDK and offload all the processing and even the tracking and logs and everything in Azure Machine Learning as we did. And then we tested the model, and the model deployment I can do through the code, or I can actually do through a portal. And I showed you how we can do through the portal. So if we can go to the models, and if we can go to wait time prediction, that's the model we registered. That's the place that I just talked to you that we can deploy the model. So I click on deploy, and this time, yes, I want to deploy this model as a web service. And the reason is we are going to have real-time prediction. Deploying this model as a web service and defining all those components that I just described in the previous use case will take probably a couple of minutes, because what it will happening is on backend, it will launch a container and having that image to create that operating system that can host your data and your model and do the deployment. When I'm done and clicking on deploy, if I go to the endpoint, you will see the list of all trained models that they are deployed and they're ready to give you a service. Again, just saving the time, I clicked on deploy before. It took me almost 5 to 10 minutes to make that endpoint ready. And when I came to the endpoint, I saw that, well, I have a model that is deployed and I have an endpoint for that. That can actually predict what's going to be the wait time. So let's see what are the information that we can grab from wait time. If I click on wait time, the model in the details, you can see there's a REST endpoint. And this endpoint actually can be used like an API call to put the input and retrieve back the predicted outcome. So wherever you are in this planet, you can just use this URL, and if you have the key, or if there's a key defined for that, to just put the input of your hospital information and get the wait time prediction back as a JSON file in your application, in your notebook, or wherever you're actually calling this code. So again, with just a deploy button, and you can actually code that as well, I was able to create a service that can do this prediction through a URL. If I want to test that quickly, and we're going to test together, here you can actually put some information and just click on text. These are actually the features that we can utilize, and you can have the results as this is the wait time prediction, let's say 62 minutes. But if you want to consume that endpoint, that service that is deployed, there are some consumption example in different languages, let's say Python, that's the way that you can do the prediction for the model which is deployed and is listening to anyone that want to do the prediction. So I define my input features in like a JSON file, and then calling that URL as I just showed you. And lastly, it will print the results or print the error if there's any other issue. So I just Control A and Control C, just copy that, and I want to test that action in Notebook. And of course, some deployment logs. If you are curious to know more how the model is deployed in a container, you can certainly check that out. But now let's check that model that has been deployed, and if we want to see if that real-time prediction can happen or not. So I go to Notebooks, and I go to Stream, which is again a Jupyter Azure Machine Learning Notebook. That can be a Jupyter Notebook as well. But before testing the streaming, I just want to test to make sure that this wait time prediction is working. So I click on the wait test notebook, and I copy the consumption Python code that Azure ML created for me and paste it here. I just added some random inputs to test the model. So I have my compute running, and just let's run it. I want to click on run, and let's see what's going to be the outcome. So you can see the result, which is the wait time prediction per minute, just immediately got created and predicted without necessarily me loading any model, any pickle file. And the only thing that I needed was my input and the URL of that model. I didn't define any key. Well, it's not best practice for security, of course, just wanted to make it simple and showcase you how we can do the prediction when we have deployed the model. And again, regardless of where you are, any machine, as long as you have access, you can certainly execute this code and have the prediction, and you leverage it in your production. So now the question is, we want to have a production layer that the prediction will be streamed from all these new inputs coming in, and real time, I want to predict the wait time and showcase that as a dashboard to have that real-time solution. So we don't have a kind of real streaming data coming right now, but I somehow simulate that. So I created an streaming Python code. And what I'm doing here, just in a loop, I'm loading the data that I have as an admission, and one by one, sending to my production model to do the prediction and have the predicted wait time as a near real-time prediction. I think I ran it yesterday. If we check, it is running right now, and I think it's done, but let me run that again. And someone asked that, are you using Event Hub? Yes, and I will showcase that quickly. That's why I need to install Event Hub as a receiver for that streaming data. So I just executed the code for streaming data to be installing Event Hub. And it is installed. And now I want to run this code that will stream the input. You can see that based on different inputs, I'm calling the URL and do the prediction, and to on and on again to have the real-time prediction for each input. I click on run, and let's see if it can predict based on the streaming data. So we're waiting for execution. And again, please feel free to ask any questions since we're waiting for the code to be running. All right, so as you can see, the results are getting predicted one by one. So this is a simulation that the patients are coming in, and we have the wait time prediction on and on changing for different hospitals. So how we are now able to visualize that in a dashboard and have some streaming analytics on the top. Let's get back to the architecture and just quickly check where we are to talk about the rest. Now we are here. We trained the model using Azure ML connected, Azure Databricks connected to Azure ML. Now you want to have a streaming analytics to grab the predictions that we are now predicting in real time from Azure ML to visualize that in a dashboard in Power BI. So in order to enable that, we are going to touch a new service called Streaming Analytics that is connected to Event Hub that I will showcase you quickly. So let's get back to the portal and see what is streaming analytics. Again, you can just type streaming analytics on the top, or if you have used that in the recent resources, it's already here. This is an event hub that I defined to actually grab the data from Azure ML. But what I'm going to do, I want to send that to Power BI using streaming analytics. Streaming analytics is a service that not only can get the streaming data from event hub, at the same time, you can do some transformation on the top you want. But I'm keeping this very simple right now. I started the streaming analytics before, and what I'm doing here, I am selecting everything that I am receiving from Azure ML, which are basically these predictions that, as you can see, they're running. So I'm receiving all of those, and I'm putting that in the Power BI. That's a dashboard that I want to have real-time prediction. And you might question, how did you connect to Power BI or Azure ML? Well, if you go to the input part, my input is coming from Azure ML. So I have defined that as a streaming input. If I click on that, I just simply say that this is the Azure Machine Learning Workspace name, some credentials, and I tested the connection and clicked on save. The same thing for Power BI. My Power BI is the destination, the output that I'm going to stream the data in. So I click on output. Not only I want to have this streaming data being visualized in Power BI, but also I want to keep track of all this real-time prediction of wait time in my data lake. So my output are two. And the same thing, I connected to my Power BI using some credentials that are blurred here because of security. And then when the connection is done, I can test the connection and then just come back to overview and click on start. That will start streaming and show me some monitoring capabilities of how the data being actually streamed. And just a question from Hussein. Yes, I use Event Hub for the streaming part, and also I use Azure Machine Learning to create those streaming. So this Azure Streaming Analytics is grabbing the data from Event Hub that is also created from Azure ML. And again, if there's any other question, please feel free to ask. I'll regularly check the chat as well. So right now, the Azure ML is doing the prediction, and the streaming analytics is grabbing the prediction from Azure ML. And now we have to check if the Power BI is actually doing the prediction for us. So I have logged into my Power BI, which is a cloud service that you can publish your dashboard that I showed you the Power BI on desktop to cloud to give others access to see that dashboard and also have some real-time streaming analytics. So if I go to my dashboard, you can see that those streaming predictions that we are doing in Azure ML is continuously coming and changing actually this component, the wait time as we're doing. So if I go back to my Azure ML notebook, which is actually do the prediction, whenever we have a new wait time prediction, it will immediately at the same time affect the prediction. As you can see, it keep changing. I can see the waiting time prediction average here based on different locations, or these are the hospitals. I can check their wait time changing. Or if I want to know what is the wait time prediction by provider type, physicians or nurse, I can have them here. And based on different admitting specialty, let's say the family medicine versus cardiology, if there's a huge amount of difference for the wait time, that can be giving me a hint that maybe there's optimization chance that we can check why a specific section of that specific hospital is not performing versus others. And that real-time insight is really powerful. So that was just an example that having a component, predicting that component, and having batch prediction, and at the same time real-time insights. And I just want to welcome you that think about how these capabilities and how these pieces be connected together can be further customized for a specific use case that you have in your mind to enable that capability and empower yourself, the team, or probably the end user in healthcare that you're planning for. Before ending the demo, I just want to make sure we will have also enough time. So I want to finish the workshop a little bit faster to make sure, just in case if you want to have some interactive Q&A. But let's talk about the last portion, which is explainability. And also you showed interest on fairness, which is also one of my favorite. And I know that's a challenging portion as well. But let's see how we can simplify that application in Azure ML to give some more hints, specifically in healthcare, which is very important as we're dealing with healthcare status of people and patients. We have to make sure there's not just a black box that doing prediction and probably affecting a specific category of the audience. So back to, again, if there's any question, I'm just emphasizing, feel free to ask. It is totally interactive, and don't hesitate to share anything if any part of these components is vague. We do have questions coming in. Can a Spark streaming be used instead of Data Factory? Yes, actually, I tested that before Hussein as well. Remember, I did the prediction and streaming to the Event Hub using Azure ML Notebook, this one. You can use a Spark streaming as well to stream the predictions as we are now streaming the predictions running right now to a Spark using a Spark to Event Hub, and then streaming analytics will grab that and push it to your Power BI dashboard. So yes, you can, and you have the flexibility as well. And again, because that model is deployed in production and you just in the URI, this model can be called in Databricks in any location that you're in, any platform, even on your computer, to just call it and get the prediction. So the short answer is yes, you can. Linda's asking, I know this isn't common to write data out of Azure, but have you had clients who wanted the model output to be also copied to on-prem databases? If you ask about the feasibility of that, I would say yes, like you have the flexibility of hybrid environment. And there are some secure ways that how you can connect your on-prem to the cloud. Some of them is as simple as having an express role or a VPN that your organization is running. And because your data lake or all these capabilities are inside the virtual network and your on-prem network is connected to the virtual network that you have on Azure, so that will be secure to pair these two and connect your on-prem services to the cloud. Being that said, Data Factory can move data from on-prem to the cloud or from cloud to on-prem. Let's say now the predictions that you're doing are stored in data lake, but you said now I want to move from data lake to an on-prem database. So there can be a separate Data Factory pipeline to do so. But I would like to also challenge this concept that you should have probably a specific reason of, is it really necessary to move those data back to the database? Because one of the main reasons that we use in data lake is having the scalability. We wouldn't be worried about if the data is image, text, or tabular. Maybe the on-prem database that you have just hosts tables, like a data warehouse. The other thing is we want to have a scalability. Now we are keep growing this data set. These predictions are happening, let's say, every day. We have some other use cases, other applications that they are generating data. So maybe right now you're not dealing with big data, terabyte of data, but in the near future, we might face up with the situation that our on-prem capacities, because they're not scalable, we cannot further host a data set there. So we need to have a cloud-based storage to do that. The other thing is, let's say now you have historical data. Let's say I am pushing these predictions to an on-prem database. And after a couple of years, I have some other databases and all these historical predicted wait times. Now you want to train another machine learning use case, and I want to do big data or distributed machine learning. So I need data, and now all those data sit on-prem. So you need to probably move them to the cloud. That can be one solution to do that prediction or training again. So I would say that definitely makes more sense to have them on cloud, but just having a short answer to your question, you have the flexibility of moving data from cloud to the prem or on-prem to the cloud. I'm checking if there's any other questions. If I miss any question, please let me know, or if you have more questions, please add it here. So I think we have probably 10 more minutes. So let me go back to the explainability and fairness portion, which is the last part. Let's say right now I have this wait time prediction happening, but before showcasing this dashboard for the end user, for healthcare providers, medical staff, I want to know what is it safe to actually say that as a data scientist that wait time prediction is working properly, and I know there's no black box concept around. Some people, some end user, specifically healthcare providers, wouldn't necessarily know, for example, the deep learning model that you use to train this regression or that light GBM, and they want to know how it makes sense that you're telling right now 48 minutes for a wait time for a specific hospital, but another different number for the same hospital, but for a different section. So in order to provide explainability that can be understandable for even non-technical people, we can showcase that explainability dashboard I showed you in Azure AutoML that it was created automatically. But even if you want to have more flexible and more comprehensive dashboard, you can create them in Jupyter Notebook. Now I'm using the Azure ML notebook. So I have a responsible AI. I copy that notebook to copy the main components to run the code together. It wouldn't take too much time. That's why I wanted to run the code together here. If you're welcome, Linda. If you want to ask any further questions, please feel free to type your question here. Okay, so what I'm doing first, I have to install that interpret module. Again, interpretability, fairness, they're all open source communities, but they're all further customized to work with Azure ML and AutoML that we just showcased that. But you can still leverage these open source capabilities and even contribute. So after installing, I just want to import the modules that I want for explanation and even interpretability and the fairness. And now, well, first I want to say which model I want to explain. Again, I'm grabbing the Veta prediction model using the same ID. You know that how I grabbed it. We used the same thing when we wanted to deploy this model. So I am just running this to grab the best model from this AutoML that is predicting wait time. And now it is serving my Power BI dashboard. And then I want to connect to the data set because if I want to explain a model, I need to get a data set, put it as an input for the model and let it predict and then explain how the model is doing the prediction. And I'm just setting up some explanation. I want to do regression and these are some inputs and this is the model that I'm inputting to do the explanation. The rest are some fixed modules that you have to import for any explainability that you want to have. So I'm just quickly running them to come up to the dashboard section and I'm now running explanation portion. The great thing is you can deploy the model and also deploy the explanation at the same time as a pickle file. So when I am doing the prediction right now, streaming for wait time every, let's say, second, at the same time that API call can retrieve the explanation part of the model. So if the model is keeping saying me every second, the wait time now prediction is 67, 68, 69. At the same time, it can tell me I use these features with this feature importance to tell you the wait time now is 67. Now I use this feature with this feature importance to tell you what is the wait time that I'm predicting. So you can deploy them on cloud. That's why I wanted to actually store that explanation as a pickle file to deploy them beside my model deployment. But let's skip that part and now just showcase the dashboard part that I want to showcase you here. So here from widgets, I am running my explanation dashboard. I think it stopped. Let's wait for the notebook to be loaded. Okay, I'm just clicking on run. So what it will do, it will create an explanation dashboard using the model that I'm having as an input and then the data set that I defined here. Let me scroll down. This is the fitted model. This is the data set. And I want to have raw explanation for the raw features that I use for AutoML to train that wait time prediction. The widget that is will be showing here, you can use that inside the notebook, but I wanted to actually make it bigger. So what I'm going to do, I will actually open the widget in a separate portal using the link that is actually giving to me. So I'm opening the link here. So the widget will be showcased here. And we will go quickly step by step through different tabs. And we have 10 minutes left, so we can cover that quickly. The first tab that it will show me the overall model performance. Here we can have the predicted output of the wait time, the range within a box plot. Different quartiles, the median, and how some of the predicted are out of the casual range and distributed equally different part of the plot. And then in the cohort, I can change any of these tabs with clicking on. I can specify, let's say I want to have the prediction plot versus age, let's say. And the age can be defined in different bins, let's say 1 to 5, 5 to 10 years old, 10 to 12, and so you can certainly change it. So I will keep it at default. And now you can see how the prediction is changing versus different ages. You can see that right now it's helping me to explain the model. All the explanation that I'm providing and sharing with you right now, it is part of the interpretability that I'm providing for that light GBM model that is predicting the wait time. And you can go further and play around and do any kind of explanation for the model performance you want based on the choice that you want for this axis. The other thing is, let's say I want to explore the data set that I use for training, or the data set actually I'm using for testing based on the data set that you put it as an input when you were defining the explainability. So I just click on the data set explorer, and since I'm opening so many tabs, it might take a couple of seconds to load that again. Okay, anyways, I might open that again, or let me close some extra tabs. So we saw that Power BI dashboard. We don't need ML anymore. And I think we need to keep this because that's the widget that we have. Okay. We hope we can run the portal again. Okay, let's see if the widget is working. Perfect. Now it's loaded. So in Dataset Explorer, we can have the aggregated plots or individual data points. With clicking on individual data points, and again, sorry, it's a little bit slow because of so many tabs we open. There you go. We have the individual points that again, I can change these axes. The DX code is one of the examples of the features that I had, and I can change it. Let's say based on the service line, I want to select, and instead of having index, I want to have the predicted value. I want to see the different service line versus the predicted value, which is the predicted Y, and select. And you can see the Dataset Explorer has colored, and this color is based on the intensity of the predicted value. I can change that as well, let's say based on age, to have 3 dimensions of explainability based on the Dataset Explorer. I want to have gender as a color indicator. Oh, sorry, I could have maybe add, okay, that's fine. So here you can see how different service lines had different predictions versus the gender that we had. Again, you can customize it in a way that makes more sense for you for the part that you're going to explain. But as of now, I'm just showing you as an example how you can explore the data set. Even going further, right now, we saw the Dataset Explorer, the model performance. I want to see how features are affecting the model outcome. We have 2 definitions for feature importance. First, the aggregated feature importance, which is in general, regardless of each individual data points. In general, how model is putting weights on different features to do prediction. You can see the arrival time is the most prominent feature. That makes sense because I created and simulated labels using arrival time. The location, because of different hospitals, they have different kind of probably operation, and that's how it was a top feature to detect their waiting time. And again, still, as I showed you before, I can scale it to have some more feature importance. If I click on any of them, let's say location, as a feature importance, it is telling me that click on a feature above to show a dependence plot. What does that mean? It will show me how the feature importance for location of the hospital is changing through different hospitals. Each of these codes, as you know, are hospitals. You can see for some of them, the location of the hospital was an important feature for predicting the wait time. For some hospitals, they were not that important. Let's check, for example, the gender or the age. We can certainly check any of those you want to see how that individual features in the importance of them is changing when we go further for different predictions. But now I'm curious to know further to detect each individual data set, how they were predicted. Let's say now we have a patient with a specific gender, with a specific disease, and all those features, and we predicted the wait time would be 50 minutes. And now the question is, how did you come up with that prediction for this specific individual input? So that tab will help me to actually click on any of those individual data points that I want. I just clicked on one, and you can certainly change the index to, let's say, change it to predicted value. And then it is showing me which features were the most important one to predict that specific output, which is an individual person. And the same thing, I can have the individual plot for that specific feature. Right now, let's say I want to again change it to gender, or change it to, let me change it to gender if it's changing or not. Okay, because gender is categorical, it might not necessarily show me a trend. But as you can see, for example, in this individual input, regardless of the age, the model prediction was the same. So age was less prominent feature for detecting that individual prediction. On the other hand, there's a what if scenario that you're thinking, well, what if for this specific input, if that patient was male or female, does it really affect the predicted wait time? Or right now, this patient with all this information is coming to this specific hospital. Let's say if I change the location of the hospital, does it really change the wait time prediction or how it is changing? So the current predicted value is 69 minutes, but let me change it to a different hospital based on the ID. So, okay, and I clicked on that. It is a little bit slow. Let me add it 100. I hope it wouldn't close the portal because, okay. And as you can see, the predicted value changed to 59. So it's telling me that the same feature, the same patient, just changing a feature like location, that will change the predicted value as we just saw. So again, this is a what if scenario. What if this feature was this, was that, how it would change the prediction of the model. So it was a quick overview of all end-to-end how we can have explanation for the model and dig in from the model performance data set all the way to individual predictions. That can be a powerful tool to showcase how the model is performing and let it make more sense that how we are predicting this individual outcome. Now, when I was doing the explanation, just quickly sharing also that it will give me the chance of how do I know if my model is fair? If you are male, or if you're female, does it really make sense just because of the gender your wait time should be changed? That's a question. And defining the fairness is not a just technical issue. It's a framework assessment, it's a governance that you have to define. And these technical tools can just quickly help you to have some initial high-level hints. So again, this solution, I just want to make sure, is not a standalone and complete tool to define if the model is fair or not. So I'm just executing the fairness part. It will give me another dashboard, the same thing that we have with the explainability. And let's say now I want to know, I feel that this feature is sensitive, the provider type. If the provider's type is different and the wait time is different, is it fair to say that this provider type is not doing a good job? That's why the wait time is high or low. Or maybe that makes sense because there should be a change. So again, you have to define the fairness by yourself. Or if you want to give a loan to someone and you're going to predict if that person is eligible or not, having the gender of male or female shouldn't be affecting what's going to be the prediction, and we have to make sure that all end-to-end solution is fair. So just as an example, I selected the feature and I thought that that provider type is a sensitive feature that I want to see if my model is fair or not. So I'm clicking on next. It is showing me that sensitive feature, and these are the categories: physicians, dentists, and then I click on next. It will ask me, how do you want to measure the performance? Well, with mean square error. How do you want to measure the fairness? I want to see if the model is fair based on, let's say, maximum mean absolute error. And clicking on next, it will take probably just a couple of seconds to show me a dashboard that how your model is performing for these different admitting provider type. And then from there, you can decide whether you're going to call it a fair model or whether you as a decision maker to call it unfair model. And then you can mitigate that unfairness. That can be a separate discussion as well. So it's taking for a while. I think it's done. And yes, you can see, for example, how the distribution of the prediction is changing. And as you can see, for example, for dentists, we have probably more less variant versus physicians. And it might raise the question that does it fair to say that one of these subcategories are not doing a great job, that's why the wait time is changing, or not? That's an unfair and a biased model that we have to mitigate. But that's a tool to just help you, and decision is all based on a human decision. Thanks a lot. I just wanted to make sure that I will cover this part as well. We are almost done within the time. I'll quickly cover the page, the question. Is there a link for a streaming example of ML using? Yes, there is. We can, if you go to, I think we don't have time actually to search to share the link. If you go to Microsoft Docs, just Google, and then on the top just shows Azure Machine Learning. There's a section called streaming, and there's an example of how to use Event Hub for using that as an example in Azure ML. And Hossein, feel free to message me. I can send you the link as well. Does Microsoft has free services for university students? Well, some of them, they have some free tiers, but it should be confirmed within the business group to make sure that we have free services for university. So Hussein, I'm not sure to make sure that I can confirm that, but probably there might be a chance to do so. If you have any questions, please to add. And just to wrap up the demo, I just wanted to have this demo as a story to share with you how we can start from a business requirement and all the way going to the production layer and having different type of prediction and enable the solution through using these different components and connected together. All of these components that by itself can be a separate topic and be a detailed discussion, but I hope so for now within these 2 hours, you found it fruitful. Again, if you have any questions, even after the call, feel free to ask and send me a message. And thanks a lot for dedicating your time within these 2 hours. Again, if there's any question, please feel free to ask. Otherwise, David, if you're over the call, the floor is yours. Thank you.
Hey, all, thank you so much, and thank you, Mohammed. It was great to have you share so much information, and I know it was quick, it was condensed, it was fast, but I hope that everybody was able to follow. And if not, we'll provide the videos for this and for the other sessions as well. So just bear with us. We usually do a little bit of editing, and then we'll send those over for you, as well as any additional resources. I'll go back to Mohammed and ask if he has anything else he'd like to share, any links or so on, and we'll include those in what we send over. So AKS, yeah, great. Can the sessions get recorded, please? Yes, they will. For tomorrow's conference sessions, in some small instances, I would say less than 5%, companies have PR that don't allow us to share their information, don't allow us to record it and send it. In those cases, we can't, but I'm not sure what the status is for tomorrow's sessions as well as the workshops. I believe almost all, maybe one or two can't be recorded, but anyways, in the event that we have permissions, we can as well. Mohammed, for those who want to get in touch with you, what's the best way? Can you provide an email or a LinkedIn contact, or what would you suggest?
Absolutely. I will type down, I think my full name is not shown in this chat, but I will type down my name here that you can use the same to contact me on LinkedIn. And I would be happy to support any further question or discussion you have. So I just type my full name that you can find on LinkedIn.
That's perfect. Thank you so much. Perfect. Well, I think that's great. If anybody has any questions, you know how to get to Mohammed, and thank you, Mohammed, for being so generous with your time and for the follow-ups as well. I hope everybody found this enjoyable, and I will be back on at 1 p.m. today to introduce our second workshop, or actually the third of the day, which is the Introduction to Graph Neural Networks and its applications in drug discovery, from Ali Mandani, head of machine learning at Cyclica. So I hope to see you guys then. Thank you so much. Enjoy your afternoon, and we'll see you tomorrow for the conference sessions. Thank you, Mohammed. Take care.
Thank you, David. Thank you, everyone. Have a good day.